Hi everyone. As it comes from the title, I'm going to talk about the building assessment system, and my particular point is going to the rating schemes and their inapplicability to evaluate the free-running buildings. It can be divided in two parts, my talk. It's first, building thermal performance evaluation and evaluation of free-running buildings. My means from the condition, because I use these two terms, condition and free-running. When I talk about the condition building, my means is to achieve the thermal comfort in the building. We are loading energy for heating and cooling the space to bring the indoor environment in the range of thermal comfort. But in the free-running, we don't allow the energy for space heating and cooling. We just run it and use the natural ventilation and take the advantages of the environment to provide indoor temperature comfortable. So these two concepts, it's assumed that these two be related to each other. That means if we can have a building that provides us indoor comfortable using the natural ventilation, so it should work when we run it in the condition mode. There should be a significant relationship between thermal comfort and energy use. But my data shows there is a relationship, but the strategy that we use to improve the thermal performance of the free-running building and thermal performance of the conditioned building, it differs. That means the strategy that we employ for improving the passive architectural design a bit differs from when we have a critical climate and we have no choice. We have to load energy for the space heating and cooling. That's what I'm going to show. Sorry. I know you all knows about it. What was the objective, and to make the conclusion whether we have been successful in achieving the objective or not. Why we developed the rating system, and as a subset of evaluation system for evaluating thermal performance of the building to respond to the objective of sustainable development. Energy consumption is growing, global warming and greenhouse gas emissions, so the sustainable development in all fields was proposed as a solution. And in the building industry, we said, so what should we do to improve building quality by more energy efficient building? And how we design an energy efficient building? Which building is more energy efficient? That's the main question. Whether a building with the low energy consumption, this is an assumption in this concept. But if a building doesn't need energy,
Can I just put it on?
that's okay. No, let me do. It's okay. So which building is more energy efficient? That's the main question, for which many regulations and standards in different countries and different regions have been developed based on the technology and based on the architecture they design. To develop energy efficiency, as an energy policy, some change the energy price in different time, higher price in the peak time to encourage the public to use less energy. These are just different policies that they have been used and encourage people to use renewable energy. But for energy efficient building, we use the energy and thermal comfort as two indexes to evaluate the thermal performance of the building. So building with less energy requirement to achieve thermal comfort is better one. That's the whole assumption. So this is again the, oh God. I reviewed different systems and different evaluation system, and I found this is a part of the old schedule. This is just a small part of it. I just want to show you that the energy that I highlighted, energy is the main index in all of the system as an indicator to evaluate the thermal performance of the building. Even it is just for evaluation energy efficiency or it is to evaluate building in terms of the sustainability, they include many parameters such as water consumption, building management, energy consumption, different, and whether sustainable materials, but all of them include energy. You can see many rating systems and software have been evaluated. Each year, they are increasing. But fundamentally, they are the same. And they carry the similar problem. And you see the parameters that they... Which one? Oh my God. Just could you help me to see how the light is coming? This one?
The top one.
The top one, okay. Okay, no. Oh, okay. You can see the energy is the main parameter in all of the system. So this is not the main problem in the matters accurate. All the country and all the software has the same problem. And the thermal comfort, they all claim we are trying to provide indoor comfort and encourage designer to employ strategies with lower energy, achieve thermal comfort. That's a claim. But how it's going? The main parameters that have been defined in an evaluation system, first is defining of indicator. And define some parameters as a default, such as occupancy scenario. We all know that we cannot include all occupancy scenario because the real life differs from what we use in the simulation. We have to compare building in a similar condition. So there is no choice. We have to consider same condition as a default for occupancy scenario and for thermostat setting that is defined based on the thermal comfort in a particular climate. But if we change the similar condition and the result change, which one is better? That's another issue. So we have two issues. First, indicator, and the second one, the parameters that have been considered as a default. If they change the result, the accuracy of the system goes under question. For each climate, it differs because, as Sue mentioned that, she make my work so easy. Different comfort zone is defined based on the climate. For the hot arid climate, differs because the people are more adapted to their climate. So it is different. They use simulation program, and what designer is doing by changing the building variables and the fabric of the building is trying to improve the building quality and its design. And they defined boundaries for classification. Its boundary is based on the point, 100 points, 50 points, or A, B, C, or gold and silver, or different classification is used in different countries. The indicator that is used, extracted from the energy, they compute the annual energy requirement based on the megajoule or megajoule per square meter, megajoule per volume. They adjusted in different rating systems, they have adjusted. But they all have been extracted from the energy. They define thermal comfort based on the adaptive model or PMV. For evaluating in the free running model that we don't have energy, we compute degree discomfort hours. That means we run the simulation and we see how long the defined zones, the indoor environmental temperature is out of the thermal comfort. We compute all these hours and we call it discomfort degree hours. So there should be a relationship between degree discomfort hours and energy consumption. Because when the temperature goes out of the thermal comfort, so the air conditioning, it turns on automatically in the simulation program. The problem with the index that we are employing to evaluate the efficiency of building is, in this case, that we consider building is conditioned, its efficiency is more related to the efficiency of appliances. If we insulate building without considering the climate, good insulated building and using the best efficient appliances, we get the best result. So this is the efficiency of mechanical engineering. What about architects? That's the main problem. Some people say, oh, okay, we don't consider the efficiency of appliances. We consider as a default, so to make a comparison between the old building. But again, in this way, best insulated building gets better results. And the other problem When you look at this graph, this line shows that the energy consumption per square meter around the world is reducing. However, no, sorry, oh my God. What's happening? Okay. This line shows the total energy consumption, this is in the residential building, is growing up, but based on the index that we define for energy efficiency, it's reducing. What's the matter? The part of it is related to the population. The population is increased, that's right. The number of the building is increased, but that's not the all of the story. Based on this index, the efficiency is related to the floor area. Why? That was my assumption. I used 3 typical buildings, 8 typical buildings here. It shows just two of them. I just changed the floor area. So obviously, if the measurement is based on the megajoule per square meter, as the floor area is increasing, they get the better results. That the larger house get the better stars from the rating system, because it is divided by the floor or the volume of the building. And if we change the index to megajoule, smaller house get better results. So that means the efficiency is strongly related to the floor area. That's not true. Again. Then I change the index. I run the building in the free running condition. Turn off the air conditioning. Just compute the degree discomfort hours. You can see by increasing the floor area, it is not related to the floor area. Why? Because it is related how the air ventilation goes through in. In this concept, the size of the opening and where they are located is much more important. But the accurate people, they believe that we include the air ventilation in computing the cooling energy consumption. That's true, accurate works better than the natters, but it still doesn't work for the free running building. These two graphs, they are a bit different. In the first one, I just compute degree discomfort hours during a year, and the second one, I weighted them. I gave them a weighting because if we have 3-degree temperature higher than the comfort zone, the percentage of dissatisfied people differs from if we have a 1 degree higher than the comfort zone. So I weight the hours by a factor which is related to distance of the temperature to this distance from the thermal comfort zone. That means if we had 2 hours with 1 degree higher than the comfort or lower than the comfort zone, this is equal with when we have 1 hour with 2 degree higher or lower than the thermal comfort. It looks to be more accurate, and Richard Didier, who is the top of the thermal comfort expert, he accepted this one is better. But anyway, both of them shows that there is not a relation between the efficiency and the floor area. But for the energy base, you can see it's strongly related to the floor. This is not by a study, it is done by the Veronica and her PhD students when they compare the actual performance of the building and then put it in the rating system. They see it got 1 star, it is passively designed in the other light, but this shows this is the monitoring of its indoor temperature. It works very well. They monitor it for 1 year, for 1 year. I think, yeah, during the summer and winter, it works very well. And occupants were satisfied. But when we put it in the rating system, it got just 1 star. The problem is because this building is designed in a passive manner. And it should be run in the free running mode, not in the condition mode. It is not dependent on the energy. That's why this type of a building, passive design building, earth building, cannot be evaluated in the current rating systems. This type of buildings cannot be evaluated in the energy-based assessment system because basically this wind catcher that is used as a traditional vernacular Iranian architecture in the hot arid climate, this type of building, they really don't need cooling energy for space cooling during the summer. They use the natural ventilation, but this cannot be evaluated in the not just the rating system, all the assessment systems that have been developed and all works based on the simulation programs. This one cannot be evaluated because, again, this is in the humid climate close to the Caspian Sea. They cannot be evaluated. In Iran, they use as a standard heat conduction. Building with low heat conduction sounds to be the better buildings, but it works for the cold climate, not for the moderate climate that it is assumed to use more natural ventilation. In another study, we compare the result for the buildings that have cross ventilation. They use a cross ventilation. And some of the apartments that, no, it's not a matter. Their opening is closed. We saw the range of the energy consumption differs when the building gets the benefits of the cross ventilation or not. That means the classification to give the value to a building for this type of building differs from the other buildings. Whether the designer wants to use a natural ventilation or not, the classification for give them a grade, 1 star, 2 star, or 3 star should be different. And if I want to come to the conclusion, that means free running building should be evaluated in a system and conditioned building should be evaluated in another system, but we all living in any country have different climate. In some countries, such as Australia or such as Iran, we have even moderate climate. We can construct free-running building in moderate climate that are passively designed and they don't need energy for space cooling and heating. In this region, we should promote people and we should encourage public to apply for passive design architecture. But besides, we have some climate, such as, for example, here in Perth or Darwin or Canberra, we cannot have a building without turning on the air conditioning during the winter. So we should keep both of the assessment in one system, but we need an integration and give more value to the type of a building depends on the climate. If the climate allows us to use and take the advantages of the environment, so we have to promote the free running building and give more value to them. And if not, so give more value to the conditioned building, but with lower energy consumption. To show you that the strategy that we are employing to improve the thermal performance of the free running and conditioned in the free running mode or conditioned mode, just bring some examples. Here is a typical single-story building. I run it in a conditioned mode and add an insulation layer. This one shows its performance in the free-running mode. Its performance when I add insulation layer, the number of discomfort hours is going up. That means insulation layer doesn't work for the free-running building in the Sydney climate. But when I run it in the conditioned mode, you see the insulation layer increasing the resistance will improve the thermal performance of the building in the conditioned mode. That's obvious. But why it is happen? It refers to for free-running building, refers to the summer performance. You can see here, this is the summer performance, and for the winter performance. For the winter performance, for both of them, the insulation layer works very well. But for the summer performance in the free-running mode, you can see for the free-running one and the condition, there is no advantages for the free-running because it doesn't let to higher temperature goes out from the opening, from the building envelope. That means, depends on the climate. If we have more energy consumption for cooling or heating, we should put the priority to the design to improve its summer performance or winter performance. That's what when designer is sitting and try to improve its architectural design using the simulation, he should first think which type of design is appropriate for this climate and which strategy have to be employed. Here, I changed the construction from heavyweight to lightweight. You can see the same results. For free running and for condition one, you see it sounds that they don't go in the same direction. They are different. And for the more analysis, it is due to the differences in the summer performance. Wall color as another option, the building parameter that I chose this parameter based on what is defined in the accurate software that is used in Australia. The parameters that an architect can play with it to improve the quality of the building. I just used these 70 parameters and I got the same result. You can see for the free running, differs from the condition one. Floor insulation, again the same result. Then, so you can see this is a parametrical sensitivity analysis demonstrated that the strategy that we can employ for improving the performance of the free running building differs from the condition one. And when I put them in order, you can see how much it is important. For free running building, when I put them in order, the order differs for the condition one. That means we cannot employ similar strategy, depends on the architectural design. Then I try another analysis. I use the regression analysis. This is a long story, I don't go through the detail. Just to confirm that the result that came out from the sensitivity analysis is true, I use the regression analysis and then I put the strategies that I employed in order. So again, for free running building, differs from the condition one.
What's your vertical left-hand scale? We don't know.
This one? Yeah. What's the difference?
So what does it mean? What is it?
Oh, okay. I employ different strategy. These are the variables. How much the openable, for example,
the vertical.
This one, its effect, the amount of how does this one, for example, the more effect, this is 0.6% effects on the energy consumption.
Okay, so there's...
Yeah, the value, how much it can...
So the bigger the better.
The better, yeah. For a designer, it's better to employ this one as a strategy to improve the quality. But for the first one is the same, but its effect on the conditioned building is higher than the free running one. But someone differs. For example, as I show you in the previous slides, for the insulation layer, no. For conditioned building is better, but it doesn't work for the free running. That means the effect of each strategy in reducing energy consumption or in reducing the number of degree discomfort differs for the passive design or free running building, or it is conditioned mode. Another problem was the parameters that have been considered as a default. One is occupancy scenario. Many people believe that we cannot include different occupancy scenario because we have numerous occupancy scenario. We don't know how people behave in particular in residential building. In office buildings and commercial is predictable, but in residential building we don't know. What we said is if we change the similar condition and the result change, so which one is better? So I tried, let me go to the second, here. The scenario one, this is what is used in the accurate software. In the accurate, a residential building is divided in the living zone and the bed zone. The time that has been considered to the living zone is occupied between the 6 a.m. for living zone, 6 a.m. to midnight, And for the bed zone, it is occupied between midnight to 6 a.m. And thermostat setting for the Sydney climate, if I can remember, is between 20 to 22. And for bed zone is 2 degrees lower because it is assumed they just can use the blanket, and so it doesn't need to be exactly the same as the living zone. Then based on the information I got from the ABS, from the Australian, the lifestyle in Australia in the residential building, I defined different scenarios. That means each zone is occupied in different time. Then I compared the results. For the first scenario, when I put them in order, and then I changed the scenario, the big difference was between scenario 1 and scenario 4. In scenario 4, all the zones are occupied for 24 hours. But the first one is based on what is defined in the accurate. You can see the order change. So if this one, the light blue one, for example here, gets 2 star, gets, for example, 4 star here it gets 2 star. So which scenario is better? They have been compared in a similar condition, but we get different results, different stars. Therefore, it's better we improve the accuracy of the rating system by defining multiple occupancy scenario. And it will be very good and very, I think, as a success step if we add this to the real estate. If someone wants to rent a house, to know which type of the building is better for them. And if someone wants to design a building, which kind of building, which type of the building is better to reduce energy consumption. The final proposal that I proposed based on some calculation and employed some algorithm I proposed this method that includes multiple occupancy scenario and includes the performance of the buildings in the free running mode and in the condition mode, but for different climate, this line changes. That means building would be evaluated, would be assessed in the condition mode, and they get until 6, same as what is happening in the accurate, from 0 to 6 star. Then it is run in the free running mode, and it gets from 0 to 6 star. Depends on the climate. If the climate is a moderate climate and we can have such a free running building there, so it gives more value to this type of the building and more value to this kind of running, this line can change for different climate. But the aggregation, if building from the condition gets 5 star and the free running gets 3 star, it doesn't mean it gets 8 star. No, based on the algorithm that I defined, if someone is interested, they can go through my books and there is more detail has been explained. It depends on the climate. 5 star from condition and 3 star from free running. Might building gets 6 star, depends on the climate, or it might get 2 star. If it is suitable, the climate is suitable to promote passive architectural design, it gets 3 star. But if it is critical and we have a critical climate, we cannot have indoor comfort condition during the summer in particular, we better to give more value to the condition one. That means 5 star from condition and 3 star from running, the building might get 6 star. In this way, actually, we are encourage public and designers to think about a type of architecture, not just think about appliances, and not just think about using the more insulation. They are trying to take the benefits, they take advantages of the climate response. That's the objective of sustainability, not just reducing the energy consumption. By the concept of the indicator is the energy, so in my opinion, we go in the wrong way. And we lost the pressures of the vernacular architecture that they have been worked. So, and they are amazing, they are still working. This is true that we cannot, in the modern society, we cannot have high-rise building by employing the vernacular strategies to improve their quality. But still we can use it, we can adjust it. That's what we are trying to improve the quality of the wind catcher, to employ it in the high-rise buildings. The traditional one doesn't work, but we use the mechanism to improve the quality of each step by changing the section and by changing the material and adding some other materials to grasp the pollution. The main problem that we have, and we cannot take the advantages, in particular in the high crowded cities, cannot take the advantage of natural ventilation, is the pollution. We doesn't let the air comes in because of it brings pollution. So we use the microorganisms and use the planets integrated with the surface of the wind catch to absorb the pollution and put more humidity on it, and then airs come in, so we can take the advantages of environment again. That's all my story, and thank you for your attention.